Hello everyone. So today we will start a second lecture of artificial intelligence and the topic is search. So search parameter of uh, all of AI, what choice are we searching through? That is actually known as problem solving, neural language, computer vision, machine learning and motion planning. So, first we will go through the problem solving. Uh, Problem solving search algorithm in artificial intelligences. Search algorithm are one of the most important area of artificial intelligence. And this topic will explain all about the search algorithm in AI. So, in which first we will learn about problem solving agent. After that, we will learn about the search algorithm terminology, and after that, properties of search algorithm, and after that, types of search algorithm. So, search algorithm are the one of the most important area in artificial intelligence. So, this topic will explain all about the search algorithm. So, first, let's start from the problem solving agent, right? So, in artificial intelligence, search technique are universal problem solving method. So, a rational agent or a problem solving agent in AI mostly use these search strategy or algorithm to solve a specific problem and provide the best results. So, problem solving agent are the goal based agent and use automatic representation in this topic. So, we will learn a various problem solving search algorithm. Okay, so mainly uh, they are mainly two type of search algorithm, right? So after we will first learn the search algorithm terminology, and after that we will cover the types of search algorithm. Okay, so what is search algorithm strategy? Okay, uh, what is search algorithm terminology? Some terms are actually used in search algorithm. So first, what exactly that first we will learn. Okay, so first terminology is search. What is the meaning of this word search? Searching is a step by step procedure to solve a search problem in a given search space. A search problem can have three main factors. First one is a search space, second one is a start state, and third one is a goal state. Obviously, when we have a very large space of searching for the searching, then definitely we should think about where we have to start and where we have to end this search, right? So, at the state where we starting the search algorithm, that is known as start state, and where this technique is over, that is known as goal state, right? Um so first we learn about the uh, search space. So search space represent a set of possible solution which system may have. For example, see, when you are trying to go from Jaipur to uh, Ajmer, right? And you have multiple way, right, to reach the Ajmer, right? So first of all, what you will find the best space, your best path for reaching the Ajmer, right? So for reaching the Ajmer through the best path, you have to apply some searching technique, right? So you will search which path is more better in terms of everything, in terms of time, in terms of cost, everything. So definitely you will apply some multiple techniques for finding the best path, right? So same like that, search space is a way, right? In this example we are talking that the search space have a if we have a four way for reaching the Ajmer, right? So this four way is actually a search space, right? So search space represent a set of possible solution which a system may have, right? Now what is start state? It is a start from where agent begin the search, okay? Wherever agents start the searching, that is known as actually a start state, okay? Next point is goal test. It is a function which observe the current state and return where the goal state is achieved or not. Goal test means, see, definitely from I'm taking example that we have a four way for from reaching Ajmer to Jaipur, right? So same goal test, it is a function which observe the current state and return whether the goal state is achieved or not. So definitely some test we applied, right? And that test or that function, that algorithm definitely give a result to you, right? Whether you are reaching or not from that way, right? So that is actually known as goal test. Next terminology is search tree. So a tree representation of search problem is called search tree, and the root of search tree is the root node which is corresponding to initial state, right? It means that, see, whenever we start searching, then definitely we have a one start state, right? And from Jaipur to Ajmer, definitely there are so many in between area you will found, right? So whenever you reach to some new destination, that is actually known as node, right? And you made a path, right? That from after Jaipur you just go to the Ajmer road, and after that you reach some new place, right? So that new place is actually a node. So this path is actually a tree, right? It is actually known as a tree. So next next topic, next terminology is action. So it gives the description of all the available action to the agent, right? It gives the description of all the available action to the agent. Next terminology is transition model. So a description of what each action do can be represented as a transition model. Means that definitely in action, all the description are available, that what action to the agent, right? What action are available to the agent, right? Now transition model, a description of what each action do, means you have a multiple action available. In transition model, for all action it is defined that what is the description of that action, okay? That is known as actually transition model. Next one is a path cost, okay? It is a function which assign a numeric cost to each path. It is a function which assign a numeric cost to each path. See, in a normal general day-to-day life, example, definitely if you are going from Jaipur to Ajmer, definitely you should choose either bus, train, or personal vehicle, right? You can choose anything. Now the point is definitely all the fare is right differ to each other, right? So in which you will have to firstly found that the which one is a more efficient, right? Efficient to you, right? So that is actually known as path cost. Okay, it is a function which assign a numeric cost to each path, right? For example, there are four-way for reaching Ajmer. Definitely, maybe a one path contain a toll tax or one doesn't. So when you go through that path, then definitely for adding the cost, you have to add that toll tax also, right? So because of this toll tax, definitely uh, um, uh, cost value, that is price, differ from for each way, right? So that is actually known as path cost. Next one is a solution. So it is an action sequence which leads from the start node to goal node. Okay. um, Solution is what? It is an action sequence which leads from start node to goal node. Next terminology is optimal solution. If a solution has the lowest cost among all solutions, see, now we have a four-way from reaching Jaipur to Ajmer, and you go through every way, right? Now you just found that which way is more efficient, which way is having a low path cost, right? Now you have four solution, right? You have four solution, yani means you can reach from Jaipur to Ajmer in a through the four-way, right? So this four-way are actually a four solution. But now the point is which one is the optimal solution? Optimal solution is the solution which have the lower cost among all the solution. So from the set of solution you found a single optimal solution which have definitely a lower cost, right? So these are actually terminology of search algorithm, and these terminology are further used in the algorithms. Okay. Now the point is second topic is properties of search algorithm. So definitely some properties they have in all the search algorithm, right? So following are the four essential property of search algorithm to compare the efficiency of these algorithm. So what are that points? What are that essential properties? See, first one is completeness. Second one is optimality. Third one is time complexity, and fourth one is space complexity. Okay, so these four terminology you can say, or these four search algorithm essential property through which all the algorithm are actually compared, then which one is more better and which one is not better, right? So what is completeness? A search algorithm is said to be complete if it guarantees to return a solution if at least any solution exists in any random input, right? Means what is completeness? A search algorithm is said to be complete if it guarantee to return a solution if at least any solution exists for any random input, right? So this means this is a complete. So whichever algorithm are actually guarantee to return a solution, at least any solution exists for any random input, so that algorithm will definitely a complete, right? So this is known as completeness. Now the point is what is optimality? If solution found for an algorithm is guaranteed to the best solution among all other solutions, then such an algorithm for it said to be an optimal solution. Means if a solution found for an algorithm is guaranteed to be the best solution. See, you have a multiple set of solution, right? So now you found that which one is a more best way, right? Means which one have a lower cost path and whatever. So that is actually a optimal search, right? Now the point is, if a solution found an algorithm is guaranteed to the best solution, means they always guarantee that if you choose this path you will definitely got a lower cost. Okay, so that solution is actually known as optimal, right? So next one is a time complexity. What is time complexity? Time complexity is the measure of time for algorithm to complete the task. See, there are so many algorithm we have, right? And there are different type of input set also we have. So all the algorithm are not suitable for that all input, right? So this different search algorithm are actually uh, given a best input. It depend on the what type of input you choose, right? What type of input you chosen. So optimality, so time complexity means definitely maybe for the same input, one algorithm took 1 minute time or second algorithm took 2 minute time. It might be possible because that input is actually not suitable for that algorithm, so it took too much time. So the point is, what is time complexity? So time complexity is the measure of time for an algorithm to complete its task. Third one is a space complexity. It is the maximum storage space required at any point during search. At any point during the search. So as the complexity of the problem. So what is space complexity? It is the maximum storage space required at any point during the search as the complexity of the problem. See, I'm taking a one example. Whenever you start a searching, then definitely a set of input you applied, right? Set of input you applied. So for storing that input, and also in between, there are so many things are happen, right? So for storing that in between result, you are needed some space, right? You are needed some space in between whatever happened. In between steps you need some space for storing that in between solution. So a algorithm which need a at most space for completing this search, that is known as space complexity. Okay, so this is actually a four properties for the search algorithm, and by measuring this property we can say that which search algorithm is more better and which one is not, right? And I already told you that this search algorithm, which one is a more better, it's depend on also the input also. For example, input is not suitable for that algorithm, then definitely in that case the time and space will be consumed more from that algorithm. So it completely depend on the input. And which one is a more better? It was checked by these following four property: completeness, optimality, time complexity, and space complexity. Definitely optimality should be high, completeness should be high, time complexity should be low, and space complexity should be definitely low, right? Now next we will start a types of search algorithm. Okay, what type of search algorithm are present in the artificial intelligence? So based on the search problem, we can classify the search algorithm into mainly uh, two-way, right? First one is a blind or uninformed search, and the second type is informed search. Okay, so point is, what is uninformed or blind search? So the uninformed search does not contain any domain knowledge, okay, such as closeness, the location of goal. Okay, uninformed search doesn't contain any domain, like like closeness, location of goal, nothing like that. So it operate in the brute force way, as it only include information about how to traverse the tree and how to identify leaf and goal node also, right? Uninformed search apply a way in which search tree is searched without any information about the search space, like initial state, operator, and test for the goal. So it is also called blind search. Uh, it examines each node of the tree until it achieves the goal node. So this is the main reason behind that it is known as blind search. Even it doesn't know whether uh, which one is a more closer, which one is a more nearest, nothing like that. It just traverses all possible way. Okay, it just traverses all possible way, and after completing a set of solution, it found that which one is a more optimal, right? So in uniform search, it first find all the possible solution, and after that it apply uh, which one is a more optimal. So after that it apply the optimality rule, and found which solution is a more better. So it can be divided into mainly five main type. That is, first type is breadth first search, second type is uniform cost search, and the third type is depth first search, and next one is a interactive deepening depth first search, and bidirectional search. So in uniform search, see, uh, this is mainly five type of uninformed or blind search, right? And we will discuss about this later, definitely. um, Firstly, we learn what is inform search, and what type, how many type it is defined, right? We will first learn about this. So what is inform search? Inform search algorithm are domain knowledge. In an informed search, problem information is available, which can guide the search, and informed search strategy can find a solution more efficiently than uninformed search strategy. And informed search is also called heuristic search. See, what I told you in uninformed search find all the possible paths, right? All the possible solution, all the possible goals, right? But in informed search, it just apply a one more function that is called heuristic function, and that actually minimize this problem, that in the uninformed search we have to found every path, right? And after that we apply the optimality rule, and then we found the which one is the optimal solution. But in uninformed search, one extra function we apply with the algorithm, and that function is actually known as heuristic function, and that heuristic function actually minimize the uh, problem finding, right? Goal finding state space, right? So definitely, obviously, uninformed search is more better, but still, uh, on some inputs, it is not given uh, as such goal or as such solution which is given by uninformed search, right? So a heuristic is the way which might not always be guarantee, right? Which might not always be guarantee for best solution, but guarantee to find good solution in um responsible time. Okay. See, in uninformed search, what exactly we do? We actually apply brute force technique, right? And as we know that brute force technique is actually finding all the way, right? All the way, all the possible solution, or it apply all the possible way to find the goal node, right? So but in the in the uninformed search, we doesn't apply that type of techniques. We actually apply here heuristic technique. So a heuristic is the way which might not always be guarantee, right? All not always be guarantee to best solution, but guarantee to find good solution is reasonable time. And informed search can solve more complex problem which could not be solved in another way. An example is uninformed search algorithm is a traveling salesman problem. Traveling salesman problem is the example of heuristic search, right? And there are mainly two type of informed search are available. That is A star search and greedy search. There are mainly two type of search are available in the informed search. Okay. Next, we will start from the uninformed search. Okay. So uninformed search is a class of general purpose search, right? Class of general purpose search algorithm which operate in a brute force way. Uninformed search algorithm do not have additional information about state or search space other than how to traverse the tree. So it is also called a blind search. Okay, that's why it is actually called a blind search, in which it doesn't have additional information about state or search space. But in the informed search, as we know that we already add some extra information, that is a heuristic function we added, that actually found a already a pre some knowledge about the next step or something like that. Okay, so that have actually a pre knowledge about that path or something like that. But in informed search, we actually apply a brute brute force way, so it doesn't have any knowledge. It doesn't have any knowledge. um, so the point is, the some following are the various type of informed search algorithm, that is breadth first search, depth first search, deep limited search, iterative deepening depth first search, or uniform cost search, and bidirectional search. So these are the some examples of uninformed search. We will only go through the breadth first search, or okay, depth first search. Okay. because only these two searching techniques are in our syllabus. Okay, so we will only go through the breadth first search and depth first search. So point is, what is breadth first search? Breadth first search is the most common search strategy for breadth first search is the most common search strategy for traversing a tree or a graph. So this algorithm searches breadth-wise in the tree or a graph. So it is called breadth first search. And this breadth first search starts searching from the root node of the tree and expand all successor node at the current level. So before moving a node to the next level, the breadth first search algorithm is an example of general graph search algorithm. Breadth first search implementing using FIFO queue data structure, that is first in, first out queue. Okay, data structure. Breadth first search will provide a solution if any solution exists. If there is a no solution exists, definitely it couldn't provide you. Means, for example, there are set of inputs are available and you are finding some particular input. So if you are applying through a BFS, if that key input which you search, that search key input are available in that input set, definitely it found, otherwise it couldn't found that input set. So definitely BFS will provide a solution if any solution exists. If it does not exist, then definitely it couldn't provide that solution. So, if there are a more one solution for a given problem, the BFS will provide the minimum solution which require the least number of steps. It required lots of memory since each level of the tree must be saved into the memory to expand the next level. So definitely it required more space. And BFS needs lots of time if the solution is far away from the root node. For example, maybe that search key or search input are actually reside at the leaf node. Then definitely it is far from the root node, and it took time. So that's why the BFS need lots of time if the solution is far away from the root node. So see, um, in this example, uh, that is a tree structure we are given here. Uh, we have shown the traversing of tree using breadth first search algorithm from the root node S to goal node K. See, in which S is a root node and K is actually a goal node. Means definitely K is searched by the user. Okay, so K is a goal node. So BFS, breadth first search algorithm traverse in layers, right? So it will follow the path which is shown by the uh, arrow, and traverse path will be what, S to A to B, and B to C, and C to D, and D to G, and after G to H, H to E, and E to F, and F to I, and I to K. Means, see, they have to traverse so many paths, right? From S to A, first path, A to B is second path, B to C is third path, C to D is fourth path, D to G is fifth path, G to E is sixth path, and G to H is sixth path, H to E is seventh path, and E to F is eighth path, and F to I is 9, and I to K is 10. Means it should have to traverse 8 path, at least 8 path, and then it reach to the K node, right? So see, the time complexity of BFS search algorithm can be obtained by the number of nodes, right? By the number of node traverse in the BFS unit until the slowest node, and where the okay, where the D is the depth of slowest solution and B is the node of every state. So the time complexity is T of D equal to 1 plus B square plus B cube plus up to so on plus B to the power D. Okay, D is what? D is actually a depth, right? So by finding the solution, what solution we found? T of B equal to order of B to the power D, right? So what is the worst case, worst possible case of time complexity is B to the power D. That is where D is the depth of the tree, and we can say that the depth of the slowest solution, or D is the uh, node of every state. Okay. Next one is the time complexity we have to found for this same algorithm. The space complexity of BFS algorithm is given by the memory size of uh, frontier, which is B to the power D. Means same space complexity and same time complexity are needed by the breadth first search algorithm. Okay. Now we need to check the completeness and optimality of this algorithm. So BFS is the complete, and which means if the slowest goal node is at some finite depth, the BFS will find a solution. Means definitely if that whatever you search, okay, whatever you search, if that present in that uh, input set, then definitely BFS will found that. Okay, BFS will definitely found that key, search key. Okay, next is the optimality. BFS is the optimal if path cost is a non-decreasing function, or the depth non-decreasing function of the depth of the node, right? Depth of the node. So definitely optimal BFFS is also optimal because see there are so many paths it traversed, and finally it found the solution. So definitely there will be lots of solution are present, but that definitely there are a one path which definitely give a lower cost, and also that found the solution also, right? Also that found the solution. um, so see first the problem how this BFS search is actually traverse for that searching key. See, from the S node it start searching from the root node, okay, that is from the S. So definitely this S is firstly put in the queue, and after that it found that there are two way from the S. Okay, there are two way, that is A and B also. So as we know that breadth first search is actually a traverse from level to level, right? from one level to two level to three level. Okay, so as we know that at the root node is definitely reside at the level 0, right? So from level 0 to level 1. So what exactly done after that, it first add a and after that b in the queue. Okay, so as we know that we are in the breadth first search, we are using a queue data structure. So definitely, as we already traverse s, so it firstly move out from the queue, and from the back side or a end side of the queue or a rear side of queue, it put a and after that b also. And from the front side, s is actually traverse, so it mark as a traverse and remove from the queue. So now at the front of the queue, a is present, right? So it mark a as a traverse, and because a have two children, right, c and d, so c and d will be add from the rear side of the queue. So definitely now a is on the front, after that b, and after that now c and d are in the queue. So as c and d are properly inserted in the queue, now a is removed from the queue because it already traversed. So now which one is on the front? Now b is on the front. So here there are two paths, right, g and h. So again it insert g and h from the rear side of the queue. So now what are the current status of the queue? B is on front, after that C and D is available, and now G and H are also available. As G and H are inserted properly, so it means that B is properly traversed. So B is marked as a traverse and removed from the queue. Now which one is a front, which one is on front of queue? Now C is on front, so definitely C have to traverse. So now it checked that there are two paths from the C, one is E and second one is F. So definitely E and F are also inserted from the rear side of the queue, it inserted, and C is removed from the front side. Now which one is on front of Q? Definitely D. So it traversed D, and D have no children, right? So D it just mark at it is traverse and removed from the queue. Now G is definitely on a front of a queue. Now G is traverse, and it found that G have only one path, that is I. So is this I is actually inserted in the queue and mark G as a traverse and remove from the queue. Now which one is on a front of Q? Definitely H is on front. So H is traverse, and it found that there are no such a way from H to any other. So H is marked as traverse and removed from the queue. Then now current state of queue is E F I, right? E is on front, then F, then I. So firstly it marked E as a traverse. Okay, and it firstly check that which one is a next node. So it found that there is a K is present, so it insert in K, and after that it insert K in the queue and mark E as a traverse and remove. And after that definitely on the front F is present, F have no such children, so it mark as a traverse and remove. And after that I is present, so it mark I as a traverse because I has a no children. And after that it found that K, and K is actually your search key, right? So it matched, and the result will be given by the that it found, right? So this is a technique. Now see, some homework are given to you. These quiz are given. Okay, just take a screenshot and found which one is the answer for each question. Okay. So see again. This is a quiz. Question number one. Question number two. Question number three. Question number four. Question number five. Okay. So today we just over this topic. Now from the next lecture we will start the depth first search, depth first search algorithm. Okay.